Okay, so coming in for marks, okay, really don't overthink any of the questions, okay? If you're looking for the period of a simple pendulum, it's 2 seconds. You're looking for its length. You have a formula that tells you about how to calculate the period of a pendulum using length and gravity, okay? Grandfather clock, this is also a pendulum, okay? It's telling you about the different lengths, okay? Adjusting this clock for different gravities. Okay, number 3, also a pendulum question, right? We're looking at what the acceleration due to gravity is on this particular planet where this pendulum is oscillating. Okay, a wrecking ball is also a pendulum. So like the first 5 questions, or first 4 questions or 5 questions are about pendulums. Okay, so in question number 4, there are 2 different pendulums. One is being used as a comparison. Okay, now, the small pendulum is 0.5 meters in length, and it's just a string and a stone. Okay, the student observes that swinging back and forth over a small amplitude, the wrecking ball makes 1 oscillation in the time it takes the stone to complete 5. Now, in terms of significant figures, this 5 is not measured, it's counted. And you are absolutely certain of any numbers that you count, because you cannot have uncertainty in counting, only in measuring. In other words, that 5 is not part of your significant digits. Okay? Counted numbers don't count, often enough. Okay? All right, so you're looking for the length of the wrecking ball. Okay, question number 5, again, pendulum question. You're looking for its period. You're looking for how long it would have to be to double its period, and then an explanation as to why that number is not just double the length. So spoiler alert, it's not double the length. Okay. Number 6, pendulum questions. Gee, there's a lot of them. Okay, so looking for the length of a pendulum oscillating on the moon that has the same period as the pendulum oscillating on the Earth, remembering that the moon's gravity is 1/6 that of Earth. Okay, question number 7, this is a tough one. All right, so I'm going to give you some important tips and hints for this one. In this question, our first situation, we have 1 mass hanging from a vertical spring. Okay, so just mass 1 is hanging from this spring. When that is the case, the frequency of the oscillation is 10 hertz. The frequency is 10 hertz. Then another object is added to that system. So the second situation is the same spring, but now there are 2 masses, mass 1 and a second mass. Same spring, but now there's more mass. The first mass and the second mass are hanging on the spring. When that is the case, the frequency is reduced to 5 hertz. Okay? We are looking for the ratio between mass 1 and mass 2. As a hint, there's no way for you to calculate the actual masses here. But you could find numbers that represent them instead. You're looking for their ratio, not their actual masses. Okay? So you've got a couple of calculations here, but know that it is impossible for you to actually calculate the real masses. But we're only looking for their ratio. Another important thing to keep in mind is that in both situations, the spring is the same. That means one of the properties of the spring that's really important for masses on springs does not change. You don't know what it is, but it's the same in both situations. Okay. Number 8. Okay, we have a spring constant, a spring with a spring constant of 1,526 newtons per meter. It's oscillating. Its frequency is 3 hertz. What mass is suspended from it? Okay, number 9, another spring oriented, is mounted on the floor. So it's put on the floor and it's oscillating up and down like this. Okay, a 0.6 kilogram block is placed on top of it, pushed down, and it oscillates. Find the frequency of its motion. Okay, notice how many times you're given frequency and not period. Keep that in mind. Okay, this formula is really, really important for a lot of the questions. Okay. All right, number 10, a bungee jumper is very similar to a mass on a spring. After taking a leap, the jumper oscillates with simple harmonic motion for 30 seconds. Over that 30 seconds, she oscillates 5 times. The spring constant of the cord is 53.2 newtons per meter. You're looking for the mass of the jumper. Okay. Number 11, okay, we're looking at a conservation of energy question. Okay. I think your point values are different. I updated these point values because these were ridiculous. I think this one's, are these all 3 now?
533.
533. Okay. Those are much more indicative of the amount of work required to solve them. Okay, they were definitely not 6-mark questions. I think actually they were, and then I changed them. Now they're only 3-mark questions. I just forgot to change the point values. Okay, so 11, 12, and 13 are all energy related. And that's the tips I'll give you for those. Questions?
When is this due?
I'm feeling January 10th. That's the first Friday after Christmas. They'll have to do the 8th, which is the Wednesday after. So I have not assigned anything directly due over Christmas. Okay? Indirectly due, but I didn't make anything due the Monday. Yes. Okay, come at her, guys.